During this chapter, we're going to get into similarity. So similarity is a little bit different than congruent. When two figures are congruent, their angles are the same and their sides are the same. So when we have two similar figures, it's a little bit different. One thing that stays the same is the angles are congruent. So the angles that line up are going to be exactly the same measure. What changes is the sides. The sides are proportional. So when we're thinking about scale factors, or we're thinking about similar figures, we're thinking scale factors. So we're thinking we have like a triangle, and then that triangle is being dilated twice as big, or it's shrinking and it's going to be half the size. So each side would be multiplied by 2 or multiplied by 1/2 consistently. Now your similarity statement is almost the same as a congruency statement. So you're going to have triangle A, B, C, and our similar figure is just a little squiggle line to a triangle. Let's just say for this one it's D, E, F. So that's your similarity statement. Now from that similarity statement, you can line up the angles that are congruent. So from this statement, we know that A is congruent to D. And I can mark that. B is congruent to E. And C is congruent to F. But what does it tell us about our sides? It tells us our sides are proportional, which means AB makes a ratio with DE. That ratio is going to be the same as the rest of the ratios. So the next ratio would be BC and EF. And then don't forget about our last ratio. We have AC and DF. So if I set those three fractions up, those three fractions should simplify to be the exact same scale factor. So how can we tell if two triangles are similar or not? Do we have to check every single side and every single angle? No. We have three theorems. We have AA, which is angle, angle. That means if I have two triangles and I have this angle is equal to this angle and this one's 56 and so is this one, I have an angle and an angle that are equal to an angle and an angle. So these would be similar. Side, side, side means I can set up all my proportions and they're going to all be equal. So this is like when you have all three sides on one triangle, all three sides on the other triangle. So we're going to set up our ratios and check them. So my smallest side goes over my smallest side. My middle side goes over my middle side. My largest side goes over my largest side. Well, right now those don't look the same. So we can divide them or simplify the fractions and they should come out to be the same. So 3 over 6 is 1/2. 4 over 8 is 1/2. 5 over 10 is 1/2. So these would be the same. Make sure you pay attention in the directions, which one, if it wants you to come up with that scale factor, which way you're going from bigger to smaller, smaller to bigger, because the scale factor would be flip-flopped. Okay, side angle side is very similar to our other side angle side, except now the sides have to be proportional. So let's say this is 6, this is 30, and this is 12. And then we have the same angle, and we'll just do 6 and, that's not right, 3 and 6. Well, I can see that I should have side angle side. I should have side angle side, but are my sides proportional? We have to check it. So smallest side over smaller side, bigger side over bigger side, and simplify. Those come down to the same scale factor. So yes, we do have two similar triangles by side angle side. So let's try some. Are the triangles similar? Yes or no? If so, why? So on the first one, I know that I either need side, 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 angle, side, or angle, angle if I'm going to tell they're similar. If I look at this picture, it doesn't give me any angles. So if these are similar, they have to be side, side, side. So let's set up our ratios and see if they're similar. So smallest side over smallest side, middle side over middle side, biggest side over biggest side. A lot of people don't like the decimals within a fraction, so if you want to just divide it, you can, and that gives me 0.67. I don't know why my iPad won't write that. I'm going to do the next one. 6 divided by 9 is the same thing. And then I'm going to do the last one. And that is also the same thing. So yes, by side, side, side. Next one, there's no numbers. Well, it does give me an angle. Here's an angle, here's an angle. And remember, anytime we have that X, we're thinking vertical angles. So angles across the street, across from each other at an X are equal. So we have another angle. So if we go through our list, this one doesn't give us any sides, so it has to be angle, angle if they're similar. Well, they have 2 equal angles in each one, so yes, by angle, angle. Let's look at the last one. So the last one, we know we have to have side, 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 angle, side, or angle, angle. On this one, does it give you all 3 sides in both triangles? No. Does it give you 2 angles in each triangle? No. So it should be side, angle, side. Always check it. So my angles are both 50, so that's good. These two are equal. So let's set up our proportions and see what happens. So I have smallest side over smaller side, bigger side over bigger side. I'm going to divide those and see what happens. The first one gives me 0.714, and the second one gives me 0.875. Those are not the same, so these two triangles are not similar. Okay, now we can also solve for similar figures. So I have a couple solving examples. So remember, angles are equal, sides are proportional. Angles are equal, sides are proportional, so pay attention to what you're solving for. So if I look at this first one, I need to find x and y. I love starting with y first because I think it's easier. Oh, and I forgot to give you your angles. Oops. Let me see here. Okay, so I like starting with my angles first. So I'm going to figure out what angle this guy goes with. So first off, you're told the triangles are similar. That similarity statement is right here. So what angle would angle Q be equal to? Well, angle Q would line up with N. So angle Q and N are the same. Uh-oh, I don't know what N is. I can't set those equal yet. But I do know that all 3 angles in a triangle add to be 180. So I'm going to subtract those other 2 and figure out what that angle is. Now that I have my angle, I can set them equal. 3y equals 60. Divide, and y is 20. Now let's do our sides. So the sides are proportional. So let's figure out what sides go together. So let's do NM first. So NM goes with RQ. So NM is X. RQ is 15. Then I have my other side. NL is 5. And NL, if I come up here, NL goes with PQ. PQ is 18. So I'm going to cross multiply. I have 18x equals 5 times 15, which is 75. I'm going to divide that by 18 to get 4.17. And there's your x. Now, on number 2, you can do this actually 2 different ways, and everyone always asks me, okay? But you have to be careful with what you're comparing. So for this one, since this guy is the whole side length, we want to actually look at that triangle as we have this little red triangle, and then we have a big purple triangle. So when I set up my ratios, I have to pay attention to that. So we have side 7 over whole side of the big triangle, which is 28, equals side 5 over side of the big triangle, which is 2x plus 3. Okay, so since that 2x plus 3 is the whole big triangle, I can't use just this little guy down here with the 21. That doesn't work because I'm given the whole side. That's why we set it up this way. Now we're going to solve. So I have 7 times 2x is 14x plus 21 equals 5 times 28 is 140. Then I'm going to solve it down. So I'm going to subtract 21, divide by 14, and I get x equals 8.5. There you go. Go ahead and pause and try this last one. All right, so for this last one, it's just a little bit different, but x and y are both sides, so you're still going to have to set up all of your ratios. So go off of the congruency statement. I'm going to start with x, and x is BC. So BC goes with EC. EC is 30. Next, I'm going to do 18. 18 is AB. AB goes with DE. DE is 21. And then my last one, Y, is AC. And AC goes with DC, which is 27. Once I have my ratios set up, I'm going to pick 2 and solve. So pick one with a variable, one without a variable, and cross multiply. So I'm going to pull over x over 30 equals 18 over 21 and cross multiply. If you want to simplify that first, you can. So if I divide by 3, I get 6 over 7. So 7x equals 180. I'm going to divide by 7, which gives me 25.7. Then I'm going to pull over my other side. So my other fractions, I do one without a variable, one with a variable. I can divide again, so I'm going to do 6 over 7 again, make smaller numbers. So when I cross multiply, I get 7y equals 6 times 27 is 162. I'm going to divide that by 7 to get 23.1. And there's x and y. So that is similarity.